Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of chemistry and medical entrance examinations in India. Today we're dealing with the 11th chapter in the grade 12 syllabus for chemistry in CBSE. The name of this chapter is Alcohols, Phenols, and Ethers. This chapter is a part of organic chemistry in grade 12 and it is very important as many questions have been asked for various medical entrance examinations. So without further ado, let's look at this episode, and the first question of this episode is to fill up an equation. So we have an equation, phenol in the presence of sodium hydroxide, carbon dioxide, and hydrolysis. You need to find out the product obtained from the reaction. So whether it's option A, benzene, option B, toluene, option C, salicylic acid, or option D, benzoic acid. So let's look at this equation step by step. So on the left hand side we have phenol represented by this structure, and when phenol is treated with sodium hydroxide, what happens is that the hydrogen escapes and we have an escape of water, and the remaining product will be known as sodium phenoxide. So that is this particle. So benzene ring, and then the functional group is O and A, gives you the functional group phenoxide. So sodium phenoxide is this compound. Now from sodium phenoxide you are adding CO2 and you're making it undergo hydrolysis. So basically adding water and more importantly H plus ions. So in that case what happens is that the ring stays the same but the functional group gets affected. So the sodium is removed and you get a hydrogen in its place, and the carbon dioxide is added to the ortho portion of this phenol. So you have COOH. One of the H's go here, another H goes at the top of the functional group so that the two valencies get satisfied. So this is the compound that we get. So we have an OH group and a COOH group. So this is what we call salicylic acid. So therefore salicylic acid, option C, is the correct option. If you look at benzene, benzene is just a ring with 6 sides, and toluene is a benzene ring topped by a methyl functional group. Benzoic acid is again a benzene ring with its primary functional group as COOH. There is no other functional group present. So option C, salicylic acid, is the correct answer for this question. So if you were to fill this equation, then what you would fill it with is a benzene ring followed by an OH and then a COOH. So this is salicylic acid. Let's look at the next question. Picric acid is option A, trinitrophenol, option B, trinitrotoluene, option C, trinitrobenzene, and option D, tribromobenzene. So let's first write down all of these structures. Trinitrophenol will be the same as a benzene ring with a phenol functional group, and then nitro groups across its ortho and para positions. This is trinitrophenol. If you look at option B, trinitrotoluene, then you have the benzene ring topped by a methyl functional group, and then the nitro group is added across the ortho and para positions. If you look at option C, in option C it's a benzene ring topped by a nitro group, and then other nitro groups are added to the methyl positions, the meta positions. And in option D you have tribromobenzene, so bromine and then another bromine at the ortho position and one at the para position. So this is tribromobenzene. So these are the 4 structures in contention. So we need to find out which of these is picric acid. So if you look at the structure for picric acid, you can see that it has a phenol functional group followed by 3 nitro groups, 2 at the ortho position and 1 at the para position. So therefore you can see that these two structures are similar, so therefore option A, trinitrophenol, is the correct answer. Next question. Lucas test is used for the detection of A. Alcohols, B. Alkyl halides, C. Phenols, D. Aldehydes. So let's look at each of the following options. What do we use in order to detect aldehydes? Aldehydes can be detected by using Tollens reagent test. And Tollens reagent, the reagent in question is ammoniacal silver nitrate, or AgNO3. Now for phenols, if you want to detect phenols, then the best thing to do is to use FeCl3 or ferric chloride test. In the ferric chloride test, you get blue, violet, green, or red brown colors if the solution has phenol content inside. So option C and option D are incorrect. If you look at option B, alkyl halides are best found by using silver nitrate. So this is pure silver nitrate without adding ammonia, etc. So therefore, if you use silver nitrate and you get the characteristic color, you have alkyl halides. So option B is incorrect. The right answer is option A, alcohols. Alcohols use the Lucas test, and in Lucas test they use the Lucas reagent, which is ZnCl2 plus HCl. This is the next question. Intermolecular hydrogen bonding is strongest in methylamine, phenol, formaldehyde, methanol. So let's look at our given options. In the given options, if you look at formaldehyde, formaldehyde is HCHO. This is the structure of formaldehyde. So in this structure, no hydrogen attached to the oxygen atom. So here the oxygen atom does not have hydrogen attached to it. So therefore formaldehyde has very poor hydrogen bonding. So option C is incorrect. Now what about option A? What about option B, phenol? If you look at the structure for phenol, which is basically a benzene ring topped by an OH functional group, this structure has steric hindrance. So what that basically means is that the big bulky benzene group is preventing the hydrogen from getting attached to another phenol structure. So therefore the steric hindrance makes weak hydrogen bonding. So therefore option B is also incorrect. What about option A, methylamine? So in methylamine, the problem is that the hydrogen is attached to nitrogen, and since nitrogen is less electronegative than oxygen, the hydrogen bond by the methylamine is actually quite weak. So therefore option A is incorrect. The right answer is option D, methanol. So in methanol, the hydrogen is attached to highly electronegative oxygen atom. So if you look at methanol, it is CH3OH. So 3 hydrogens bond with carbon, and the 4th bond is with oxygen. Oxygen, in order to satisfy its valency, it bonds with a hydrogen. So therefore option D is the correct option, because hydrogen is attached to oxygen, and that makes the intermolecular hydrogen bonding very strong. Option D is the correct option for this question. Now, in this question, we're asked to find out the reagent used to prepare propan-1-ol from propene. So basically we have propene, which is CH3, CH double bond, CH2, and we need to find out the best way to prepare propan-1-ol or propanol. Now, in the course of this chapter, you would have learned that propene, when reacting with B2H6, which is diborane, it forms an intermediate which is CH3, CH2, CH2B, 3B. So therefore you need 3 propene in order to create this intermediate. The intermediate is called tripropyl borane. And then to this tripropyl borane, we are adding peroxide and hydrogen peroxide in a basic medium. So now what this happens is that we get 3 CH3, CH2, CH2OH, which is propan-1-ol. So the reason why it's propan-1-ol is because the OH group is attached to the first carbon, or a carbon towards the end. So that's why this is propanol. So propene can make propanol by being reacted with diborane and hydrogen peroxide in a basic medium. So when you treat it with diborane, it goes to an intermediate called tripropyl borane, and from there, using peroxide in a basic medium, you get propan-1-ol. In order to learn more of these, you can always visit our playlist for mind maps. We have made a mind map on this chapter: alcohols, phenols, and ether. So you can visit our channel for more of such information. So for this question, the right answer is option C, B2H6 followed by H2O2. All the other reagents, when you use them, you get different values, and we will not get propan-1-ol from propene. Some of these reagents may not even react with propene to get any sort of product. And that's why option C is the correct option. Now, the final question for this episode: the most suitable reagent for the conversion of RCH2OH to RCHO. So this is to convert an alcohol to an aldehyde. So you need to find out which of these reagents is the best or the most suitable. So over here we have KMnO4, K2Cr2O7, CrO3. Now the problem with KMnO4 and K2Cr2O7 is that they are strong oxidizing agents. So you get direct conversion to carboxylic acid, that is RCOOH. So options A and B are incorrect. Option C, CrO3 also yields RCOOH. So if you use CrO3 to an alcohol, you add CrO3 to an alcohol, you're going to get a carboxylic acid and not an aldehyde, RCHO. So option C is incorrect. The right answer is option D, PCC, that is pyridine chlorochromate. So if you have RCH2OH and you have PCC added to it, you get RCHO. This is a mild oxidizing agent which is just potent enough to create an aldehyde out of the given alcohol and not the carboxylic acid. And that's why option D is the correct option. So that concludes this episode of NEET preparation. Now, as we've said, we have made a mind map of the chapter as well, so you can hit the link in the description down below if you want to access more of that mind maps. And if you want to access more of our videos on NEET preparation, you can also hit the link for the NEET preparation playlist, again in the description down below. If you want to support our channel and access more of our useful and informative content, you can always subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.